Alright, so for the first example, kind of continuing the notes here, first thing we need to do is figure out what kind of conic section we have. So what we're going to do here is look at our squared terms, and we have a 1x squared plus a 4y squared. So first off, you're adding two squared terms. It's either a circle or an ellipse, but because the coefficient for the two squared terms are different, this is going to be an ellipse. So that's the first part of this, is figuring out if we have what kind of conic section we're working with, and now we need to actually go ahead and find that equation. So again, we're going to do that by completing the square. So I'm going to put my x terms together. So I have x squared minus 6x and then plus blank, because I got to complete the square here, and then plus 4y squared. There are no other y terms. So what that means is the second half of this equation with the y terms, it is already a perfect square. There's no vertical shift, so we're actually set on that end. I do need to take my 7 though, and I need to move it to the other side. Okay, so k is 0. I can already tell that because there's no y term, which means there's no vertical shift going on, but I do have a horizontal shift. So I need to complete the square here to figure out what that horizontal shift is. So remember, this is going to be b over 2 squared, so 6 over 2 squared. So that's 3 squared, which is 9. So I'm going to add 9 to the left-hand side, and I'm going to add 9 to the right-hand side. So this becomes x minus 3 quantity squared, if you factor that correctly, plus 4y squared equals 16. So if you want to get this into standard form, remember what we need to do. We need to make sure that this is, and again, I'm looking for this form, x minus h squared over a squared plus y minus k squared over b squared equals 1. And that's going to be our standard form for an ellipse, and we'll talk about how to actually use all these components as we move through this week. But we need to know how to get there first. So to get there, in this case, we're going to divide everything by 16. That means everything. So our standard form is going to be x minus 3 quantity squared over 16 plus, and then the 4 and the 16 cancel out, becomes 1 and 4, so that's plus y squared over 4 equals 1. And that is going to be your standard form for your ellipse. So that is example D. Alright, so next up, example E. First thing we're going to do here, just like we did last time, we're going to look at our square terms. And first off, we will notice that these are being subtracted, and they have two different coefficients. So this is going to be a hyperbola. So that's the first part of this one. And again, just like before, we're going to go ahead and complete the square. Now, in order to do that, we need to rearrange our x and our y terms. So I'm going to have 25 x squared plus 100x plus blank, and then I'm going to have minus 16y squared plus 96y plus blank, even though I'm not really actually ready to complete the square on that, but I'll talk about that in a second, equals 444. Alright, before we complete the square, what we're going to want to do is get our x squared terms and our y squared terms by themselves. So that means I need to factor out in the first set of terms with my x's. I'm going to pull out a 25. So that's going to be 25 and then x squared plus 4x plus blank. And then I'm going to pull out a 16 on the second one. So that's going to give me minus 16 and then y squared plus, let's see, 6y and then plus blank. Okay, so at this point we're ready to complete the square, and again that's 444 over here. And actually, before I forget, this actually should be a minus right here next to my 6y. The reason for that is, again, I just pull out a negative 16. So that's going to change all the signs. This becomes a positive y squared, and that will be a negative 6y. So make sure we put that negative in there. So now we can complete the square. So here I'm going to have b over 2 squared, so 4 over 2 squared. So that's 2 squared, which is 4. Now be aware, since I added 4 on the left-hand side, on the right-hand side, I'm going to be multiplying 25 times 4. Again, the reason for that is this 4 is being multiplied by 25. So I need to make sure that I'm copying over that product. Do the same thing over here as well. This is going to be 6 over 2 squared. Technically it is negative 6 over 2, but you're squaring it, so I don't really worry about the sign. 6 over 2 is 3. 3 squared is 9. So for this one, we're going to go 16 times 9. And what I'm actually going to be doing here, and I'll just put it on this side, it doesn't matter. But we have 9 and 16. That is going to be 144. But it's also a negative. So make sure when you come over here, it's plus a negative. I'll just do negative. I'll write the whole thing out. So negative 16 times 9. So this ends up being 444 plus 100 minus 144 on your right hand side. So if I write this whole thing out, here's what we get. We get 25 x plus 2 quantity squared, if you factor that trinomial, minus 16, and this will be y minus 3 quantity squared, if you factor that trinomial. And then on the right hand side, we're going to have 444 plus 100, which is 544. So 544 minus 144 is 400. So I have 400 on my right hand side. So to get this into the proper form, what I'm going to need to do is, and again, just same thing, really it's very similar to an ellipse. It's going to be equal to 1. It just has a minus in its place instead of a plus here. So I'm going to have to divide everything by 400 to get this equal to 1. And that'll give me my A and my B values as well. So first off, you divide the left-hand side by 400, the right-hand side by 400. So start off with 25 divided by 400, which is going to give me 1/16. So that's going to be x plus 2 squared over 16 minus, and I'm going to go 16 divided by 400. And that's going to give me 7 over 200. So first off, when you get this, we can't have that. What we're going to need to do is do a little bit of math here, but I'll take care of that in just a second. So this is going to be equal to 1. Now here's the problem. We need to make sure that that number on top is 1, because I need to figure out what my B value actually is. My B value is not 400. It is literally going to be the denominator when the numerator has a coefficient of 1 on top. So we're going to need to fix that. So we need to figure out, and it's a real simple fix, but I need to try to explain why this simple fix works. So follow me here. What we're going to do is I'm going to take this fraction here, which is 7 over 400. And I want it to be equal to 1 over x. What I mean by that, and actually I'll even change that to 1 over b. Okay? And I know it's actually equal to b squared, and I'll get to that when we do our graphs, but what I want is, what I'm talking about here is I want this to be y minus 3 squared over b squared is what I'm looking for, which I'm just going to find that number on bottom. I really just want to figure out what that number is. But I want that number, this number right here, to equal the same thing as this number right here. So I'm going 7 over 400 equals 1. I want that 1 to be up here, and you'll see what I mean when I write my final answer, to be 1 over b. So what I'm going to do is I'm going to just solve for b, figure out what would b have to equal to make it the same as 7 over 400. You'll see it's a real simple fix. We won't actually have to do this every time. So it's going to be 7b equals 400 times 1, doing cross product. And then I'm just going to divide by 7. And you'll see all I really have to do is flip that fraction, and that's all I got to do. So this is going to be x plus 2 squared over 16. And if I want this, I want to write an equivalent form of that y term, I'm just going to go minus, not equals, minus y minus 3 squared divided by 407ths equals 1. So again, if you have, again, we have to have this be 1. That coefficient has to be 1 for our standard form. So in order to do that, if you have a fraction, literally just write the reciprocal on the bottom, and it'll work every time. You can do the math every time if you'd like to as well. It doesn't matter. But that's all we're going to have to do to kind of take care of that issue. But be aware, this is not standard form. We have to make sure that that coefficient is equal to 1 in front of the perfect squares. So that is your ellipse, and we have one more over here. And I'm going to have to make this step look really tiny to fit my last example. There we go. Alright, so last one. As you look at this one, again, you're going to look at your square terms first. So I have a minus x squared and a positive 7y squared. So first off, be aware, this is actually the same as 7y squared minus x squared. I am subtracting my squared terms. So first off, you are subtracting, and the coefficients are different, which in reality doesn't actually matter because you're subtracting them. But this is going to be an hyperbola. So we have two hyperbolas here in a row at the end. So that's the type of function that we're dealing with. So I'm going to go ahead and write this out with my x and y terms together. I'm going to have to complete the square. So I have 7y squared plus 70y plus blank, even though I'm not ready to do that part yet, but who cares, minus x squared plus 24x plus blank, even though I'm not ready to deal with it, equals negative 24. Okay, so before I complete the square, let's pull out our GCFs. I'm going to pull out a 7 for my y squared terms, my y terms. So it's going to be y squared plus 10y plus blank. And here I'm going to just pull out a negative for my second one. So I have x squared by itself. That's going to be x squared minus 24x plus blank. And again, that equals negative 24. And I'm going to add those two terms that I'm adding to the left-hand side to the right-hand side. So here I go. So this is going to be, again, 10 over 2 squared when I'm completing the square. So that's going to be 5 squared, so 25. So that's going to add up to 175 on the right-hand side because it is 7 times 25. So you add 25 to one side, you multiply that 25 by 7, you get 175. Alright, for your second blank, I'm going to go 24 over 2 squared. So that's going to be 12 squared, so 144. And again, you're multiplying that 144 by a negative 1, so it becomes a negative 144 on the right-hand side. So to keep going here, let's just wrap this guy up. I'm going to have 7y plus 5 squared, just factoring that perfect square, minus x minus 12 squared for my second perfect square. And on the right hand side, we got to do a couple quick calculations, but we got 175. I'm going to take away 24, and I'm going to take away 144. And that's going to leave me with 7. So this one actually simplifies pretty nice, because again, it has to be equal to 1 on the right hand side. So I'm going to go ahead and divide both sides by 7, and it leaves me with y plus 5 squared minus x minus 12 squared over 7. equals 1. And again, you may say, well, where's your a squared term? Well, it's 1 if you need to put that there. I mean, we will actually, so go ahead and just do that. So anyway, that's going to be your general form to standard form. We're going to be doing a lot of that. And then the next phase is being able to graph these when they are in this standard form. So that's going to be our next step. You'll see that in class next time I see you guys. So again, go ahead and practice this part, and then we'll move forward from there.